We are given three strings s1, s2, s3. We have to return true or false based on whether s3 is the formation of s1 and s2 or not. There are two conditions forming s3. First is the length of s1 plus length of s2 should be equal to length of s3, which is obvious if we are forming from s1 and s2. The second condition is the relative order of the characters of s1 as well as of s2 should remain same in the s3. So here s3 is basically formed by taking the first two characters of s1, then first two characters of s2, then we are taking b, and then we are taking c. Now by relative order we mean that we cannot take b before we have taken these two characters. In the second example we have taken a from the s1, then c, and then b. Here there is no possible way of taking the second x from s1 before we have taken y, and here we require 2x, so it is not possible, so we are returning false. Now why greedy approach will not work here? For that I have written this example. This first string is s1, the second is s2, and the third is s3. For a there is no option. We have initialized two pointers. Let's say one is here on 0 and one is on f. We are comparing a and f with this a, so we have to move this pointer, we have to take from s1, and the pointer moves to v here in the s1. Then we are taking f, the pointer moves to v here in the s2. Then this is v. Now we have to decide whether we take v from s1 or v from s2. Now as you can see in the result, if we take v from s2, then we will not be able to form b because our s1 pointer will be here and b is not accessible to us. So our only option is to take this v for this value, the third index. Now we cannot greedily determine that okay, this v is beneficial for future. We cannot see the right hand side of the string before, so we have to try all possible cases. Basically we have to try on moving forward while taking this v, also one time while taking this v. So this is simple recursion call that we are going to do, and we can optimize this further by using a DP table. So basic recursion calls are that if the current index, we will maintain 3 pointers, one for this s3 and other two are for these strings m and n. So if the character at position at m is equal to the character of I, that means we can take the character at m. Basically we have started from the backwards, so that is why I'm doing m minus 1 here, right? We will start comparing from c. Actually we'll compare this c with this c and this b. So first it will compare the s1 value, that is b is not equal to c, then this first recursion call will not be called, and next we will call this c is equal to this c, which means we can take this character and we will move left hand side for our s3 as well as for our s2. Here you might say that I have not taken the I pointer. I pointer is actually redundant pointer because in any case, in both of these recursion calls, we will have to subtract I by 1. So we can literally get the value of I with the simple formula, that is m plus n. Whatever m plus n will be in our recursion call, that will be our I pointer, because we already know according to the first condition the size of s1 plus size of s2 is size of s3. Now regarding the DP initialization, so we have reduced the DP array size from 3D to 2D, right? Because we are not maintaining the state for I pointer. We will have to have 3 values in our DP table, not 2. We are just returning true and false, but we have to differentiate between whether the value is not calculated in the DP table or it is actually false. Like if we are just maintaining true and false, in case the value is false in our DP table, we won't be able to say that this false value has already calculated through recursion, or is it the initial false value, right? So if the state is not calculated, we will keep it as -1. If it is false, we will keep it as 0, and if it is true, we will keep it as 1. So here I have written simple condition. If the size constraint are not matching, we return false immediately. Here is our DP vector 2D initialized with S1 pointer and S2 pointer, size of the S1 and S2 basically. Here is our memoization call. If it returns 1, then it will return true. For this call, as I said, I pointer is literally calculated with m plus n. If I equals 0, I've started with S1. So basically I have used 1 based indexing. That is why I'm saying if I is equal to 0, we will return 1. 1 is true. If the value already exists in DP table, we will return from the table. If m is greater than 0, since it is 1 based indexing, so if our string 1 has some characters remaining, that means n would be greater than 0, we will compare the characters, and if they are equal, we can move ahead with the I. We can move left hand side for S3 and move left hand side for S1. If this recursion call itself returns true, we will terminate our recursion function because we only need one true example, right? We don't have to find the number of ways in which the true answer is possible, right? We're just returning one fine, one right answer. So in case any recursion call returns 1, we will immediately return 1. Similarly, for the S2 string, we have done the same thing. We are moving here S2 pointer. And in case none of this recursion call returned anything, we will return our default value, that is false.